Hi, this is Scott Henson with Pecan Street. I'm here today to film the second part of our D2 deliverable videos. This shows the 3 prototype systems and the upgraded lab baseline system. There's all 4 systems. The lab system has been upgraded with the new LG battery packs that are down in there, and has the new HMI display replacing the previous mode buttons. Each system is fully wired. Batteries, contactors, circuit monitoring boards. And fully operational. The first technical document in the submission packet is the top-level assembly for the enclosures. It is a multi-page PDF showing the 3D models of the constructed energy switch systems. There are additional schematics for 3 circuit board the 6 SARM circuit board subassemblies, 3 of which are on this side of the module, or of the energy switch. The first is the SARM control board, which I have shown here. This is a multi-page schematic. Each SARM control module has 2 Arduino Due open source computing platforms on it. One is reserved for making mode switching decisions, measuring and analyzing loads and grid conditions, and the other is reserved for communications, data logging, and storage. Also on this side of the enclosure is the voltage monitoring board here. The voltage monitoring board can accept 4 DC inputs. In system we use 2, and 3 AC split phase inputs, so it knows the voltage conditions for the grid, the output of the energy system, and the output of a secondary generation system such as a generator. Also on this side of the unit is our quadruple redundant power supply. This will take 3 AC voltages in and 1 DC voltage in, so that no matter which source of energy is available, the supervisory control electronics of the SARM module are active and available. I'm now showing the inside of the front of the unit. In here are the relay drive boards and current transducer boards used to measure the individual sub-circuit loads in the house, the production of solar, the total grid usage, and the total load in the house, as well as the generator if it's connected and operating. This series of circuit breakers and contactors and current protection devices, as well as this side on the inside of the module, is covered in the system wiring diagram PDFs. It is a series of 25 pages or so that covers all of the wiring between devices inside of the energy switch and shows external connections available. Page 200 of the energy switch schematic shows the main mode switching and energy routing contactors. Many of those are shown directly in front of you. They are internal to the unit. For instance, CR522 is one of the relays used, or contactors used for the inverter, photovoltaic legacy grid-tied inverter output routing, and that is shown directly in front of you. The other ones on that sheet 200, or many of the other ones on that sheet 200, are here as well. Some internal load control contactors used for proper battery operation, including soft start, so that a sudden current connection to the control electronics doesn't damage the batteries, are shown here. And then on the right side of the unit, the remaining load control relays are available. These will be used to control all of the 120 volt loads inside of a residential structure. The last piece of custom SARM hardware is shown temporarily installed in our lab transfer switch here. This is the remote current monitoring board. This is needed to measure current for the total home usage and send that information back to the SARM over quite possibly what could be a long distance. You can only use the CT wires that are attached to the CTs for the normal current monitoring under distances of about 5 feet or so. In many cases, the home grid connection where it needs to be measured could be 20 or 30 feet or more away from the energy switch. So we have this piece of custom hardware. This is the 6th SARM board. The individual current, or the individual subcircuits within the residential structure, each one is monitored through a set of CTs. For example, this bank of CTs is numbered 1100. There is a corresponding page on the system schematic, 1100, with those CTs. In this case, we just number them house loads 9 through 16 because we don't know yet what loads those will be connected to. But that is configurable in our API so that those are mapped to known circuits within the house. And there are corresponding relays for each one of those loads here. In an installation, the output of the residential circuit breaker will be brought into the cabinet through the CT into the control relay, back out of the cabinet, and then continuing on to the residential structure branch circuits. And that way we can make use of the existing distribution panel in the residential structure and still have monitoring and control by the energy switch.